Now let's talk about how to create scatter plots for data frames. Scatter plot allows you to see is there any relationship between two variables. Let's create a data frame first. In this case, I will use 3 columns, 3 variables. It's height, weight, and shoe size of 4 persons. So I'll just run this code. So we have a data frame with 3 variables. It means that we have 3 different combinations, pairwise combinations. We can look at height versus weight, or height versus shoe size, or weight versus shoe size. Well, the simplest thing you can do is just to write plot and the data frame D. In this case, R will take all possible combinations and make as many plots as you can get. As you can see, we have a grid with 3 columns and 3 rows. On the diagonal of the grid, we have the names of the variables, the names of the columns, and then every plot is a combination. For example, here we have height as x-axis and weight as y-axis, and here it's vice versa. We have weight as x-axis and height as y-axis. So we have all possible combinations. What happens if you have only 2 columns? For example, let's create a subset with height and weight only. In this case, let's see, we will get only 1 plot, so exactly what we need. And of course you can change the labels and add a main title, like we did it for the line series plots. What else you can do? You can also create a plot for any 2 selected columns by using a relation symbol. Let me show you how it works. The idea is following. First of all, I decide which columns I would like to make the plot for, then write these columns, weight, and put this little wave in between. For R, it means that we relate weight and height. So height will be like x-axis, values along the x-axis, and weight, corresponding weight values will be along the y-axis. So it's weight related to height. Then I need to tell also from which data frame we need to take this column. So I just write data equal to D. It means take a data frame D, take columns weight and height from this data frame, and then create a plot. So if I run it, I will get absolutely the same plot as I had before. Another way to create a plot is, of course, to select the particular columns. For example, D $height, D $weight. And in this case, plot will be almost the same as in 2 previous cases, but as you can see that the names of the axis, the labels for the axis now look a little bit awkward, because it just takes this one as a name and then this one as a name. Let me show you another useful feature for the scatter plots. It's labels. So first of all, I will create a scatter plot like weight related to height, data equal to D. So this is a scatter plot. And then let me show you a function text. Let's say I would like to put a text on the plot. And let's say I would like to have it somewhere here. So the x-axis is the x-coordinate is 175 and y-coordinate is 76. So just write 175 and 76 here, and then some text, for example, label. Okay. So if I run this code, you can see that I have a text label exactly in this coordinates 175, 176. What else you can do? You can actually put several labels. In this case, you need several coordinates for x, several coordinates for y, and then several text labels. We combine this together by using function C. Let's say I would like to have another label at 180 and 72. So 180, then 72. Let me call label 1 and label 2. Label 2. Okay. So let's see what happened. I need to run both plot and text, otherwise it will keep the previous text and add a new one. So I want to redraw the plot and create new text items. So now you see 2 labels, and exactly at the coordinates we specified. The x-coordinate of the first label is 175, then we have 180. So you can see 175 and 180, and then 76 and 72, 76 and 72. That gives us a very interesting possibility. It allows us to define a label for every scatter point, for every point on this plot. How to do that? Well, first of all, remember that I'll create a new plot. You remember we have names for every row, and actually every point on this plot is a particular row in our data frame. So what can we do? We know the x coordinates of the points and we know the y coordinates of the points, right? So we can just write text d height, because height is our x coordinate and coordinates, and then d weight. And now we need labels, and we can use row names for the labels. So if we run these two lines, now look, every point has its own label. The problem is that the point is hidden under the label. But actually we can solve this by using a parameter argument pos, which is position. By default, pos is equal to 0, so it means that the position is exactly at the same coordinate as the point. But we can ask to use position 1, for example. It means the label, I need to run again the plot again. It means that the label will be under the point. Position 2 makes label location on the left of the point, and then you can guess position 3 will make a label on the top, and position 4 will make a label on the right side. Okay. What else you can do? You can change the size and the color of the points. Size is changed by function cex. The idea is that default size is 1. If you want to change size, you can multiply it, for example, to 0.75. In this case, the size of the font will be 75% of the default one. Or if you want to make it bigger, you multiply it, for example, to 125, so it will be 25% larger. So let me use 0.75, for example. So now you can see that, I need to run the two lines again. Now you can see that the font got smaller. And I can also change the color by using parameter argument col, and in this case I will use dark gray color. Now we can see that we have points, black points, we have dark gray labels at each point. This is very useful when the number of points is relatively small and you would like to identify the points on the plot. Another useful feature is changing limits for x and y axis. I will create a new plot similar to what we used before, this one. So you can see that R calculates limits using the range of your data values for x and for y. Okay, and sometimes these points are pretty close to the border of the plots, and you would like to make them a little bit, look them a little bit in the center. In this case, you can change limits manually. There are two arguments, xlim for x limits and ylim for y limits. For example, in our case, we have limits between 165 and 190. So let's change x limits, for example, to have it C 150 and 200. Okay, let's see what we get. So in this case, you see now the points are located in the center of the plot. So because we don't have any people below 165 centimeters or above 190 centimeters. So we have some space on the left and on the right. Likewise, we can also change the y limits. Let's take from 50 to 100 to 90. Okay, so now you can see that we have the same effect on the y limits. Okay, what else you can do? You can also add lines on the plot, vertical, or you can add a vertical line, horizontal line, or a line with any slope and any intercept. In this case, we will discuss only simplest cases, vertical or horizontal line, and then later I'll show you how to add any line, any curve, or any points a bit later in this course. So the function that adds a line to the current plot is called AB line. It has many arguments, but if you want, for example, to make a horizontal line, the only mandatory argument is h, and it's a position of the horizontal line. For example, if you would like to make a horizontal line that crosses 70, we just say h equal to 70. So if you run these two lines of code, that you can see exactly we have a horizontal line at 70 kilograms. Because this is a line, you can change line properties. For example, you can change the color. Let's call it gray. You can change the line type. Let's say it's 2 dashed line. And then you can change the line width. For example, it's 2. So if you run it now, you can see that we have a gray dashed line with a thickness of 2. Well, and if you want to make a vertical line, you can guess. You just use, instead of h, you can use v. Let's say it's 170. And of course, you can change all the properties as well. So now we have a vertical line at 170. And finally, one more thing I would like to discuss, and it's not related to scatter plots for data frames. It is related to any plots, creating any plots in using this basic plotting functionality in R. Sometimes it's a good idea to have several plots, so you would like to look at the several plots together. First of all, you can use these arrows left and right. R remembers all plots you created before, so you can just go to the left and see all the previous plots and then go to the right on this sequence. But that's not enough. Sometimes you would like to look at several plots all together. What you can do, you can split this plot area into several rows and several columns like a grid. And then you could create as many plots as you want to see. For example, let's say we would like to have two plots, one on the left side and one on the right side. In this case, we have one row and two columns. To tell R that we would like to have this configuration, we use a function par. Par, it's a universal function for changing any graphical parameters, for example, margins, paddings, and so on. In this case, we would like to change only the layout of the plotting area. And the parameter, the argument that is responsible for that is called mfrow. Okay, mfrow. Then you specify a vector with two values. How many rows and how many columns you would like to split your plotting area into. In our case, we would like to have one row and two columns. And that's it. Now you can create plots. Let me just copy and paste this simple plot and change color to blue. And then I create the same plot but with red color so we can see the difference. Okay. So if we run these three lines, we see two similar plots with two different colors, one on the left side and one on the right side, exactly what we wanted to do. There is one important thing. Now R will use this configuration, this layout for any other plot. So for example, if you make a third plot with green color, you will see it on the left and nothing here, because now you started to fill this layout again. So first it was blue and red, now it's green and nothing. So you have only one plot on the left. If you want to get back to the original layout or the original configuration, just specify the same function and the same argument, mfrow, and say one row and one column. This is the default layout. So in this case, you will have a plot like you expect to have. So that's it about the plots. Once again, it's just basic things. We will learn much more during this course eventually.